Continuing on with solving polynomial equations, for example D, we have this bracket squared minus 36 equals 0. So I wouldn't recommend expanding this. First look and see if there's an easier way to factor it. If we have a perfect square minus another perfect square, we can factor this like a difference of squares. So once again, it's going to factor into two brackets. You take the square root of the first term, which is just whatever's inside that bracket. Take the square root of the last term. One gets a plus, one gets a minus. Okay. And now if you look, within each of these brackets, we have quadratics. So in the first one there, two numbers that multiply to 6 and add to -5 are -2 and -3. So that can factor into x minus 2, x minus 3. Okay, and then two numbers that multiply to -6 and add to -5, -6 and 1. So x minus 6, x plus 1. Now that we have it all fully factored and there's nothing left to factor within any of these brackets, we can read off of our answers. So we have x equals 2. In this bracket we get that x equals 3. From here we get x equals 6. And from there we get x equals -1. Okay, so the solutions to this equation are x equals -1, 2, 3, and 6. So for the next one, it's a quartic. So you could use factor theorem if you wanted, but there is an easier way to do this. So if you look, it does look like a trinomial, except that the exponent on the first x is a 4, and the exponent on the second x is a 2 instead of a 1. But we can actually factor it like a trinomial because that middle exponent is half of the first exponent. So you can even kind of think of it as x squared squared minus 5x squared plus 4 equals 0. So it is this variable squared minus 5 of that same variable plus 4 equals 0. So it does fit that form of a trinomial. So if you think of two numbers that multiply to 4 and add to -5, that would be -4 and -1. And then what's going to go in front here is going to be the x squared. And if you don't believe this works, try foiling that out and you'll see that you do get back to your original. And now what we have in each of these is actually two difference of squares. So we can still factor those further by taking the square root of the first and the last. So we get x plus 2, x minus 2. And in the second bracket we would get x plus 1, x minus 1. And there it is fully factored and we can read off of our answers. So x equals -2, x equals +2, x equals -1, and x equals +1. So we have our 4 possible answers, which makes sense since it's a quartic. Now, if you had done the factor theorem, you would have had to do the factor theorem probably twice and then factor a quadratic. You'd end up with the exact same answers, but it is a much longer method to do the question. So here is our next one. So once again, you have this bracket squared minus 11 of that same bracket plus 24 equals 0. If it helps you to do a substitution, you can do that. Okay, and sometimes it does help people to see it that way. So this common bracket here, I'm going to let that represent a, or let a represent that. So I'm going to let a equal x squared minus 2x. So everywhere I see an x squared minus 2x, I'm going to replace it with an a. And now you can see that it does follow that quadratic format. So two numbers that multiply to 24 and add to -11 would be a minus 3 and a minus 8. And of course, a isn't what we're actually interested in, so we're going to have to replace it again with what we substituted a for. So I'm going to replace that a with x squared minus 2x, and I'm going to replace this a with the same thing, x squared minus 2x. And now we have two quadratics. We need to try and factor each one of those. So two numbers that multiply to negative 3 and add to negative 2 would be negative 3 and 1. And two numbers that multiply to negative 8 and add to negative 2 would be negative 4 and positive 2. And from there we get solutions of 3, negative 1, 4, and negative 2. Okay, I'm writing them all in one place. X equals negative 2, negative 1, 3, or 4. So before you expand brackets and make it more complicated, see if there's something that you can do to factor it first. See if there's a common factor in there. See if substitution helps. See if it's a trinomial or if you can group it in some way. If you can avoid doing the factor theorem, you should, because the factor theorem generally does take longer, right? It takes a little while even to find a factor that works. So what I want you guys to do now is pause the video and give these two questions a try. Okay, they are going to involve the factor theorem. And then when you're ready, unpause the video and I will put the solutions up on the screen. So here are the solutions to both G and H. So G did involve one factor theorem and then the quadratic formula. H actually involved two factor theorems and then some more factoring of a trinomial there. So our last question for today is an application question. It says the volume of a rectangular prism is 42 centimeters cubed. Find the value of x and the dimensions of the prism. Okay, so volume of a prism is length times width times height. And they gave us the length, width, and height in terms of x. And then they told us what volume was. So we can sub all those things in. So length is x plus 3. Width is x minus 2, height is x minus 1, and it would equal 42 centimeters cubed. So to solve this, we're going to have everything over on one side, and then we're going to have to factor it. Okay? Because as soon as we move that 42 over, we actually need to have all of this expanded so that we can combine the 42 and then have it all refactored. So let's start by expanding. So I'm going to choose these two brackets to expand first. And if I expanded them, I would get an x squared, I would get a 3x, and a minus 2x. So that would give me a 1x. And then I would get a negative 6. Okay, I still have my x minus 1, and it's still equal to 42. And then I still need to do the expansion of this trinomial with that binomial. So expanding that all out, I would get x cubed minus x squared plus x squared minus x minus 6x plus 6. And I can also move the 42 over, so minus 42 equals 0. And if I simplify this, I get x cubed. Those x squareds would actually cancel each other out nicely. And then minus 7x minus 36 equals 0. Now I have it at that solving equation stage. So I'm going to do exactly what I did earlier in this lesson. I'm going to factor this. So I'm going to let it equal f at x. And I need to find f at something that gives me 0. And after a little bit of work, hopefully you found that f of 4 gave you 0, which means that x minus 4 is a factor. So we can divide out that factor of x minus 4. We're missing the x squared term, so we're going to put in a 0 as a placeholder. And then we do synthetic division. So bring down the 1, multiply by 4. Add, multiply by 4. Add, multiply by 4. Add. And we get that f at x is equal to x minus 4 times x squared plus 4x plus 9, and it is equal to 0. We would try and factor that quadratic, which in this case we can't, so we're going to have to do quadratic formula. So on this side we get a solution that x equals 4, and from this bracket we do the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And if we simplify that, we will get negative 4 plus or minus the root of negative 20 all over 2. So that is a complex root. And we don't need to go any further, we don't need to simplify it, because x is a side length, or it's part of a side length, so we can't have complex side lengths, so there's no solution to this part. And that's because the solution just doesn't make sense in a real-world problem. There is no imaginary side lengths. So the only answer we have here is actually 4. Okay, so once again, as soon as you get to the point where there's a complex root in a real world question, you can say that it's not going to be a valid answer. Okay, you still do need to prove that there were no other answers, and that's why we had to do that quadratic formula and prove that it was a complex root, but it's not going to affect our final solution. So 4 is the value of x. They also wanted us to find the dimensions. So we need length, width, and height. So length was x plus 3, width was x minus 2, and height was x minus 1. So I'm just going to plug in the 4 there to get a length of 7, a width of 2, and a height of 3. So the dimensions of this box are 7 centimeters by 2 centimeters by 3 centimeters. And that is the end of the lesson for today, so you guys can begin working on your homework.